Author and lecturer Jay Seegert holds degrees in both physics and engineering. As co-founder and executive director of the Creation Education Center, Jay passionately seeks to help people establish a biblical worldview based on the authority of Scripture, starting with the book of Genesis. For the past 26 years, he has been graciously tackling tough questions people have regarding the Christian faith, especially in the often intimidating world of science, bringing it down to a level that everyone can understand. We trust that you will enjoy this presentation as Jay delivers a talk entitled, The Case from Science.
Well, thanks for joining us today for The Case from Science. We're going to be taking a look at the whole creation-evolution controversy from the standpoint of science. And the background for this particular presentation is the fact that there are a lot of people out there, you may know some of them, you may be coming from this angle yourself, is you don't really want to hear a lot of what the Bible has to say at this point, you just want to know what science has to say. Well, in many of our other presentations, we do talk about the authority of God's Word, and I think it's very important, but what we're doing in this presentation is saying, okay, let's temporarily put some of that aside, the Scripture portion aside, and take a look at what does science actually tell us about this whole controversy. So we're going to be looking at the creation-evolution controversy from the point of science. And we're going to be looking at three major areas in this particular talk. We're going to be looking at the origin of the universe, origin of life, and origin of species from a scientific standpoint. And one other little background point we need to make, and we've talked about it in previous talks, and that is that there are two types of science. There's operational science, which deals with things that we typically do in a laboratory where we can reproduce our experiments and test things over and over and over. And it produces things like fast computers, space shuttles, cures for diseases, sends people to the moon. It's great stuff. That's not really where the controversy lies as far as creationists and evolutionists are concerned. But the other type of science is called historical science. And that deals with events that happen in the unobserved past when no one was around to see it. So they're making guesses and assumptions as to what maybe happened. That's where the controversy lies. And as we look at the science today, we're going to be primarily focusing on events that happened in the past and what does science seem to tell us about that. So with that, we're going to jump in right away to one of the most basic things we can look at, and that is the origin of the universe itself. And one of the most basic questions you could ask is, how did it all begin? Whether you're a creationist, a Christian, an evolutionist, an atheist, a Muslim, a Buddhist, a Mormon, whoever you might be, your particular worldview has to come up with an answer for this question. How did it all begin? I personally think that Christianity is the only worldview that really answers this question well. Now, you've probably heard of the Big Bang, most people have, and you probably think, well, yeah, that's the explanation for the origin of the universe. And you're probably thinking it was this huge explosion in the past that threw stuff out into space and it created our entire universe. Now, if you're thinking that, you're in pretty good company because a lot of people think that, including a lot of scientists. But you'd also be wrong because that's not exactly what the Big Bang is. The scientists who study the Big Bang supposedly actually tell us what it is that in the past, everything in the entire known universe was squished down into a tiny little speck about the size of a period on a page, maybe as small as an electron. Everything in that small space. They call it a singularity. Something doesn't play well with the known laws of physics. And then it was also just stuck. It was a thermodynamic dead end, meaning it couldn't go anywhere. It was kind of going to stay there forever. But they tell us the Big Bang is the event that got it unstuck. And as it expanded, it didn't expand out into space because space didn't even exist. In fact, it wasn't even sitting there in time because they say time didn't even exist. But as it expanded, they tell us it was actually creating space and creating time. It's kind of a bizarre theory, but that's what they believe it is. So the Big Bang really doesn't explain the origin of the universe. It just says if you did have something to begin with, the Big Bang is just an event that got it unstuck. It's really not a great theory, and we'll look at this in just a little bit of detail here. Here's an interesting quote from Popular Science magazine. It said, "In the beginning, there was nothing. Then with a big bang, an almost infinitely small, hot and dense universe exploded into existence." Now, when I read that, I was on an airplane at the time, I remember, and I read it and I thought, I had a question for them, and you might have the same question. If there was truly nothing to begin with, what exploded? Good question. They're the ones who told us there was nothing, and then they said there was an explosion. I thought, okay, I'm going to give them a break because this is just the first page of the article. I'll read the rest of it, see what they say. Well, I did read the rest of it, and you know what? They never even mention again of how you get an explosion when you've got nothing to begin with. But boy, did they share a lot of other scientific detail about the Big Bang after that, but not based on real science. Then we got a quote from Discover magazine. It says the universe burst into something from absolutely nothing, zero, nada. And as it got bigger, it became filled with even more stuff that came from absolutely nowhere. Now, some people laugh when they hear this, but they shouldn't, because this is a science magazine and the articles are written by PhD scientists. So doesn't that mean that it's true? In reality, this isn't even a scientific statement. To say that everything came from nothing, this actually has nothing to do with science. This is a philosophical statement. And they have every right to say this, but they shouldn't be calling it science because it really isn't. Then we got one other quote that I like this one a lot better from New Scientist magazine, talking about how you get something out of nothing. What is a big deal? The biggest deal of all is how you get something out of nothing. Don't let the cosmologists try to kid you on this one. They have not got a clue either. In the beginning, they will say, there was nothing, no time, space, matter, or energy. Then there was a quantum fluctuation from which, whoa, stop right there. You see what I mean? First, there is nothing. Then there is something. And the cosmologists try to bridge the two with a quantum flutter, a tremor of uncertainty that sparks it all off. Then they are away, and before you know it, they have pulled 100 billion galaxies out of their quantum hats. You cannot fudge this by appealing to quantum mechanics. Either there is nothing to begin with, in which case there is no quantum vacuum, no pre-geometric dust, no time in which anything can happen, no physical laws that can effect a change from nothingness into somethingness, or there is something, in which case that needs explaining. And it's really that simple. Either there truly was nothing to begin with, in which case nothing's going to happen, because nothing can do nothing but nothing. Or there was something to begin with, in which case that needs explaining. Where did that something come from? How did it get here? How did it change into an entire orderly universe? And I don't believe that they have any good scientific answers for that whatsoever. We're going to look at something next called the anthropic principle. It has to do with the fact that it appears that our universe is finely tuned or designed for life to exist. If it wasn't set up just the way that it is, life would not be possible. And there are hundreds of examples we could take a look at. There are at least 30 just in cosmology, the study of the universe itself. We're just going to look at two brief examples here and start out with a simple analogy. Let's say you went over to a friend's house. They had just moved in. And you're looking around thinking, wow, what a beautiful home. Did you guys hire a professional decorator? And they say, no, we're actually pretty upset. The movers went to our old house, gathered everything up, put it in the truck, showed up at the new house, and literally just chucked everything in the room. And that's how it landed. You know, would you believe them for a second? No, of course not. There's no way that the coffee table is going to end perfectly centered on that rug, and the love seat and the sofa at 90-degree angles, and the coffee tables with the lamps there and the plants, and then the pictures hung perfectly on that wall. You can tell that somebody set this up the way that they wanted to. It's not an accident. Well, it's the same thing with our universe. There's no way that there's this accidental explosion that formed our nice, orderly universe. And here's the first example we're going to take a look at. The gravitational constant has to do with the force of gravity. Here's a formula that shows the force of gravity between two objects, like the Earth and the Moon. The capital G is that gravitational constant. The number at the bottom is its value. Now, I have a picture of the sun up there. It's just a reminder for me to tell a story that I usually share. When I was in college studying for my degree in physics, that's my background, physics and engineering, I was calculating things all the time, over and over and over. And then I graduated, and I really didn't have to calculate things anymore much. I was on an airplane one day for my first job traveling somewhere, and that particular day I was just bored out of my skull, and I wanted to do anything to pass the time. So I thought maybe I could just calculate something. So I got some paper out, and I looked out the window, and I saw the sun rising, and I thought, I wonder if I could calculate the mass of the sun, just from what I remember in my head from physics. I know it's pretty bizarre, you might not want to make eye contact with me, but on the paper I remembered this formula, so I wrote that down. And I remembered another formula, I wrote that one down, did some calculus on it, ended up with coming out with some number. I had no idea if I was even close. Well, when I got home, I got out my physics book and looked up the value. And I ended up being 1/10 of 1% off. And I thought, that's really cool. Flying on an airplane, I just calculated the mass of the sun. And the point here is that this stuff works. It's good science. We don't debate that. Creationists don't reject science. In fact, almost every major area of science we have today was founded by a Bible-believing Christian. This is good stuff. But the bigger question for our talk here is, why is this gravitational constant that particular value and not something else? Well, scientists have figured if you had a ruler that was so long, it reached from one side of the universe all the way to the other side, Every single inch on that ruler could represent a different possible value for this gravitational constant. So it could have been anywhere. If there was a Big Bang, the value could have ended up just about anywhere. Well, let's put an arrow here. Let's say that's where it is today. Now, we could move this arrow halfway across the universe and see how that affects us. We're not going to do that. We're going to move this arrow just 1 inch to see what happens. What we find out is moving it 1 inch, animals anywhere near the size of people would be instantly crushed. Insects would have to have very thick legs to support themselves, and creatures much bigger than that, they couldn't even survive. That's from adjusting this constant a tiny, tiny bit. So did we get lucky? There was a Big Bang and it turned out to be right where it needed to be? To me, that would be evidence that it was designed to be that way. We're going to look at just one other example here. It has to do with the cosmological constant. That's related to the energy density of empty space. You can forget about that. It's not that important. This is just another one of those constants in physics that is very precise. It's got to be right where it is, or life wouldn't be possible. Well, what are the chances that this constant turn out to be right where it needs to be? Well, they've actually calculated that. They tell us the chances that this thing turn out right by accident would be 1 chance in 100 million billion 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 billion. In case you haven't studied science yet, that's a big number. This is just telling us it's not going to happen. But what's even more interesting is, what are the chances that both of these constants turn out right by accident? Both the gravitational constant and the cosmological constant. Well, you know what? They've calculated that too. And they tell us there's 1 chance in 100 million trillion 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 trillion. A much, much bigger number. Unbelievably big. This again is telling us this is not an accident. And I agree with Owen Gingerich, a Harvard astronomer, who says a common sense and satisfying interpretation of our world suggests the designing hand of a superintelligence. I would also agree with the psalmist when it says, by the word of the Lord were the heavens made, their starry host by the breath of his mouth. God is the one who created this universe, and his fingerprints are all over it. Now that's all we're going to say about the origin of the universe here with the time that we have. We're going to move quickly on into the origin of life itself. There are 2 things that evolutionists don't like to talk about a whole lot. Number 1, we just covered. How do you get something out of nothing, and how does an explosion form a nice orderly universe? The other one is, how do you get non-living chemicals to come together to form a living cell? That's a huge problem. So let's take a look at that. Back in the 1950s, Stanley Miller put an experiment together in the laboratory to see if he could simulate the Earth's primeval atmosphere and create some amino acids. Now, why did he want amino acids? Well, amino acids are building blocks for life. They're not life itself, they're not even close to life, but you gotta start somewhere. Well, he wanted to create amino acids in this laboratory. If you get the right kind of amino acids together in the right way, you might be able to get a protein. Now, a protein isn't even close to life. But if you get the right kinds of proteins together in the right way and can fold them right, you might get a single cell. But you got to start somewhere with amino acids. So, in his contraption, he put some gases in there. Methane, ammonia, hydrogen, some water vapor. But there's one gas that he didn't include, and that's oxygen. Now, why wouldn't he put oxygen in his experiment? Well, he knew if oxygen existed on a primeval Earth, oxygen itself would destroy things and you wouldn't get the amino acids that you're looking for. So he decided, I need to leave that out. But someone else pointed out, wait a minute, if the Earth's ancient atmosphere didn't have oxygen in it, there would have been no ozone layer around the Earth. Ozone is O3. And if we didn't have an ozone layer around the Earth, the sun's ultraviolet light rays would come through and they would destroy things. So oxygen is very important there. So you have a problem. If you don't have it, you're not going to get what you want. If you do have it, you're not going to get what you want. Well, they decided to leave it out. You know, they're in a laboratory. They don't have to worry about the sunlight coming through here. So they just decided the Earth's primeval atmosphere did not really have any oxygen. Since then, we've done a lot of experiments and we determined the Earth has always had oxygen around. But again, they decided they weren't going to use that. One other element here is they introduced some sparks there to simulate lightning on a primeval Earth, because you got to energize this thing and get it going. And then one other element that they didn't like to talk about a whole lot is a trap at the bottom. If they did form anything in this experiment, they had to trap it out, keeping it out of this normal environment, because they determined anything left in that environment would be destroyed thousands of times faster than it would accumulate. So if you do get anything, you got to take it out of this atmosphere. Well, where is that going to happen on a primeval Earth? Where is the trap? Well, here's summarizing the experiment. 85% of what they formed was a toxic tar, harmful to life. 13% of what they formed were carboxylic acids, also toxic to life. And 2% of what they formed were amino acids. That's what they were looking for. They got very excited, just about claimed that they had created life in a laboratory. But there are problems with this too. These amino acids they created them in two different forms. They come in left-handed form and a right-handed form. What's interesting about this is life only consists of left-handed amino acids. But half what they created were right and half were left. Well, again, I said I'm going to try to keep everything very simple here, so here's another simple analogy. Let's say you had an absolutely huge bag filled with millions and millions and millions of red and blue blocks. You're blindfolded, and you have to reach in and pull out just red blocks. Half of the blocks are red, half of them are blue. Each time you reach in, you got a 50-50 chance of getting your red one. Now these are like our amino acids. Let's say we need to build a chain of these amino acids or a chain of these blocks. So you reach in the first time and you get a red block. Great. You put it on the table. Reach in a second time, 50-50 chance, you get another red one. Wow, great. Not too surprising. Now you got a chain of 2. Reach in a third time, you get another red one. Wow, you're getting a little lucky. You reach in a fourth time and a fifth time, you get more red ones. Wow, you got 5 now. You reach in a sixth time and oh, you got a blue one. You don't throw that back and grab a different one. You take your chain of 5 red ones, put them back in, mix it all up, and start all over. Do you think you're ever going to get a chain of 10? Probably not. That'd be really, really lucky. How about 25? Not in your lifetime. Well, you'd need at least probably 300 in a row to get a simple protein, and a protein isn't even life. So we can see it's not going to happen this way. Again, summarizing the experiment, they had the wrong materials to begin with, used the wrong conditions, and got the wrong results. Other than that, it was a great experiment. But what are the chances that just somehow it did happen? Just somehow in the supposed billions of years they tell us we've had, it just somehow happened. Because I actually have proof that it did happen. We're here today. If we weren't here today, obviously this didn't happen. In fact, if this didn't happen, we wouldn't be here today. That's what many evolutionists believe. Well, it must have happened because we're here today to talk about it. Well, what are those chances? Well, let's take a look at that. We need to take a look at some big numbers first. 1,000,000 is a very large number. That's a 1 with 6 zeros after that. You can write that scientifically as a 1, 10 raised to the 6. That's a 1 with 6 zeros. A billion, much bigger, that's a 1 with 9 zeros. You can write that as a 10 raised to the 9th. That's a 1 with 9 zeros. Those are big numbers. But those numbers aren't big enough. We need a much, much bigger number here. Well, let's look at this number. The estimated number of electrons in the entire known universe. That would have to be an unbelievably huge number. Well, you can write that number as a 1 followed by 80 zeros. That's an unbelievably huge number. So forget everything I've said so far to this point. Just remember that. A 1 with 80 zeros after it is about the number of electrons in the entire known universe. Absolutely a huge number. Okay, now what are the chances that life formed by accident on this planet? The number I'm going to show you comes from Sir Frederick Hoyle. He was one of the world's leading astronomers. He was an atheist for most of his life, but he came to the conclusion there must be a God just by studying math and science. So this number comes from him. He tells us that the chances that life formed by accident on this planet and all the supposed billions of years that we've had would be 1 chance in a 1 followed by 40,000 zeros. That is a phenomenally huge number. You know what? Let's just write this number down for a second. We'll put a 1 up in the corner of the screen and then fill the screen with all these tiny zeros. That's page 1 of zeros. Then we have page 2 of zeros, page 3, page 4, page 5, 6, 7, 8, 9, 10, 11, 12 pages of tiny zeros just to write the number down. Wouldn't you like to have someone write you a check that big? That would be great. But again, this number is so big we can't really relate to it. It's just one of those big numbers. So let's use another analogy here. Now, how many of you have ever played with a Rubik's Cube? Probably most of you have. A Rubik's Cube has a lot of different combinations to it. In fact, there are so many combinations, you've got 10 million trillion different possible combinations to a Rubik's Cube, and only one is correct. So if you're blindfolded and you're spinning away, you've got 1 chance in 10 million trillion of getting it right. So most people are going to say, you know what, that's just not going to happen. Well, let's compare solving the Rubik's Cube by accident to life forming by accident. It would be like you being blindfolded and being handed a cube, spinning away randomly, and solving it 2,105 times in a row. Is that ever going to happen? Not a chance. So why do we teach in all the school systems around the country and universities that life formed 3.8 billion years ago when non-living chemicals came together to form a living cell? There are two things that I personally believe that shouldn't be taught in the public school system. Number one is this story. Non-living chemicals come together to form a living cell. The second one is that God created everything in 6 days, and that was perfect. But Adam and Eve sinned and disobeyed God, got kicked out of the garden, and then God says, oh great, I got to send my son, Jesus Christ, to die on a cross for their sins. Now I personally believe that that actually happened, and that's true. But I don't believe that that needs to be taught in the public school science classroom or in the university science classroom, because many of those details are outside of the bounds of science. But we can teach good science. So what should we teach in the public school science classroom and in the universities? I think what we should teach is, you know what, we've been studying this for well over 60 years, and it looks, as of today, according to science, that chemicals are just not going to come together to ever form life. And so, therefore, the students can conclude, okay, if it's not going to happen by accident, there must have been something else to it, some purpose or maybe even some design. And then they can go on and teach some other good science. The students can decide for themselves what science is telling them. And they don't have to push an evolutionary agenda. Just teach good science and let the students use their minds. I also agree with Nehemiah when it says, you give life to everything and the multitudes of heaven worship you. God is the one that created life, and his fingerprints are all over that as well. But what do we do if scientists ever do create life in a laboratory? Does that disprove creation, disprove the Genesis creation account or the Bible? Think of it this way. Scientist comes on television one day and says, ladies and gentlemen, I'm excited to announce to you that after 70 years of research, we have finally created life in a laboratory, proving that no intelligence was necessary. You know, they would have proven just the opposite. It took all those years of the most brilliant scientists studying, spending millions of dollars using the most expensive equipment known to man. It shows that it took intelligence, which is what the Bible is telling us all along. Now, will they actually ever create life in a laboratory? I don't know. But even if they do, it shows it took intelligence. It doesn't have anything to do with it happening by accident. We're going to move on next to the origin of species. When most people are thinking about evolution, they're not thinking about getting something out of nothing in the Big Bang. They're not thinking about how you have non-living chemicals forming a single cell. They're thinking about how one creature slowly changes into another one. And we can kind of envision that. Some of it seems plausible when you take a look at it. So this is what we're going to look at next. Is it possible for one creature to slowly change into another one? Well, evolution teaches us that there was a single-celled organism maybe 3.8 billion years ago that slowly evolved into a human being, backpack and all. But if they were honest with us, they would tell us, well, it was actually a rock that evolved into a human being. Why do I say that? Because they believe that the earth was in a molten state and slowly cooled down over billions of years, and then water appeared on that rock, and then chemicals got in the water, and then the chemicals turned into a living cell. So ultimately they do think we came from a rock, and if you push it back farther than that, they think we came from swirling gases, and then even before that we came from nothing. But if you pictured it this way in the textbooks, it doesn't seem too believable, so you're not going to see it that way in the science textbooks. And since we're talking about evolution here, we need to define it a little bit further, and we're going to look at something called the bait and switch technique. Now, in the stores a number of years ago, they used this technique, and this is kind of how it would work. Let's say a certain retail store was advertising a really cool flat panel television, and you can't believe the price on this thing. You're thinking, I'm going to get there as soon as possible to buy them before they run out. So you rush to the store, and you get there, and you tell them you want to buy it, and they say, you know what, we really don't have that one anymore, but if you like that one, you're really going to like this one over here. And they pull the switch on you, and they try to sell you something else that costs more money, is inferior in quality, and makes them a lot more profit. So it's a bait and switch. They never had an intention of selling you that initial one. Well, I think something similar happens in teaching evolution. They teach that it's an absolute fact that there was a single-celled organism almost 4 billion years ago that slowly evolved into every other life form on this planet. But then when it comes time to, quote, getting you in the store and showing you evidence, they kind of pull a switch and they just show you varieties of animals, and they tell stories of how one changed into another one. For instance, we've got all these breeds of dogs today, about 250 breeds. I personally believe that every single domesticated dog on the planet today has descended from a common ancestor, from something like a gray wolf. But doesn't that sound like evolution? It kind of does, doesn't it? But it's really not. What's interesting is that today you can breed wolves, dogs, dingoes, and coyotes. They're really all the same kind of animal. In fact, you could breed wolves and eventually come up with something like a Dalmatian. But you know how you get a Dalmatian from a wolf? You don't take the genetic information in a wolf and start adding new information to it to produce a Dalmatian. You do just the opposite. You take the wide variety of genetic information a wolf has, you start getting rid of things, weeding it out, and pretty soon you have a purebred Dalmatian. Is a Dalmatian different than a wolf? Yes, it is. Do they call it a different species? Yes, they typically do. But how did we get it? We got it by getting rid of information, not gaining information. But evolution requires that we gain new information all along the way. So does this actually happen in the real world? Yes, it does. We can create a nice variety, but it's all within the same kind, and it's not due to gaining new information. So if evolution is true, and it actually occurs, what is the engine behind it? What's actually driving evolution and making it work? Well, they tell us there are three things. You got mutations, natural selection, and lots and lots and lots and lots of time. We're going to fly through two of these three very quickly here. A mutation. What's a mutation? Well, a mutation is basically an accident when the DNA copies itself. There's tons and tons of information on our DNA, and mistakes are made once in a while. And we call those mistakes mutations. And it produces some pretty strange things once in a while, like two-headed frogs, or two-headed turtles. This is kind of odd here, but people say, well, see, it's evolving. There's something new here. You know what? There's absolutely nothing new here. The turtle already had information to make eyes, a head, neck, shell, and legs. It just accidentally made an extra copy going the wrong way. And this guy would have a hard time reproducing. So he's not really going anywhere. It's kind of a dead end. And the whole point here is that there's no new information. But evolution requires new information all along the way. We have a brand new presentation we just came out with called Evolution Probable or Problematic. It's a fascinating look into more details of the DNA and mutations and things like that, showing that evolution is virtually impossible. Fascinating talk. If you want more information on that, we highly recommend you get a copy of that. Second element that supposedly drives evolution is that of natural selection, or we call it survival of the fittest. And this is how it works. Let's say we had two dogs, a husky and a greyhound, and they're living in the same area. And let's say over time the climate changes and it starts to get really cold out. You know, global warming's kicking in and it's getting cold out. We know how that works. Which one of these dogs is going to survive the best in the cold climate? Well, obviously the huskies. They're more suited for that. So after a while, we've got plenty of huskies because they survive and reproduce, but the greyhounds die out. Natural selection truly does explain the survival of the fittest. What it does not explain is the arrival of the fittest. How did we get huskies and greyhounds to begin with? But too many people think it was Charles Darwin that came up with this idea that somehow it's proof of evolution or the same thing as evolution. It was actually a creationist, a scientist who was a Christian, Edward Blythe, who thought of it 24 years before Darwin even wrote about it. And I think it's a perfectly valid scientific concept, but it just has nothing to do with evolution. It gets rid of things. It doesn't create anything new. The third element is lots and lots of time. We actually don't have time to discuss time here. We have another DVD that we produced called Creation in 6 Days, a biblical and scientific analysis. It goes into a lot of detail about the whole controversy of the age of the earth. Is it young? Is it old? Have we had the millions and billions of years? Those days in Genesis, were they regular solar days? Were they multiplied millions of years each? We look at it from a biblical standpoint and a scientific standpoint and sort through that whole controversy. Next segment we're going to take a look at here is evidence of design again. We initially took a look at evidence of design in the universe itself. Now we're going to switch to look at evidence of design in the living world. If you were traveling out in the desert and you were looking at some sand like this, you wouldn't be too surprised because literally the wind blowing across the sand will form dunes like this. No big deal. But if you saw some sand that looked like this, you wouldn't think the same thing. No one in their right minds thinks that the wind blowing across the beach would form these sandcastles. You can see design here. Someone a lot more gifted than me crafted these sandcastles. I'm not sure quite how they do it, but you can see design here. It's not an accident. Here's an interesting quote from Dr. Francis Crick, the co-discoverer of the DNA molecule, very intelligent scientist. He said, biologists must constantly keep in mind that what they see was not designed, but rather evolved. Now, why would he say that? because he knows as scientists look at the living world, and especially the DNA, it looks so much like it was designed, but he wants them to know, I know it looks that way, but it was just evolved by accident. There's no design there. Why would he say that? Because he's an atheist. He won't even allow himself to consider that maybe God actually designed it. So he comes up with ideas that maybe there are intelligent aliens out there that created life somewhere else in the universe where we can't see it, sent it to our planet on spaceships in seed form, and then it grew from there. Again, he goes that route because he's an atheist. He's already limited his conclusions, and he won't even consider that maybe God created life. Now we have Richard Dawkins. We refer to him quite a bit. This is what he had to say. Biology is a study of complicated things that give the appearance of having been designed for a purpose. Well, maybe they actually were designed for a purpose. But again, he can't consider that. He's one of the world's leading atheists. He won't even consider that maybe God exists and maybe God actually designed it. He's ruled that out right from the beginning. Then we have Darwin himself, who said if it could be demonstrated that any complex organ existed which could not possibly have formed by numerous successive slight modifications, my theory would absolutely break down. Well, now what did he mean by that? He meant if we ever find something that is so complex and so intricate that you got all these parts that work together and they all need to be there at the same time, it couldn't have evolved one piece at a time because it wouldn't be able to work or survive along the way. They've all got to be there at one time. Well, we've seen many things like this in the living world that basically show that evolution is virtually impossible. And we're going to look at a concept next called irreducible complexity. This is a phrase coined by Dr. Michael Behe, brilliant scientist, in his book Darwin's Black Box. And what this means is that certain things, you can't get them any simpler than they already are. If you make them simpler, they won't function anymore. And the analogy that he usually starts with is that of a mousetrap. A mousetrap has 5 parts to it. It's got the hammer, which is the mouse's least favorite part. Then you've got the trigger where you put the cheese, the trigger to set the whole thing off. Then you've got the spring that'll bring that hammer over. Then you have the latch that holds it all back. And finally you have the wooden base that holds all the pieces together. So you've got 5 parts that all have to be there in the right place at the right time for this thing to function, or it's not going to work. So how could a mousetrap evolve slowly, one piece at a time, by accident over millions and millions of years? It couldn't. It couldn't survive along the way. It couldn't catch mice. Now we know mousetraps, they're not living, but in the living world we see things that are much, much more complex than this, and that's what we'll take a look at next. Our main example here is going to be the human ear. You've probably all seen these things before and heard about them. We're going to look at a little bit more detail about how these things work, and I think that you're going to be fascinated by this. And here's the challenge. As I go through and describe this in a fair amount of detail, I want you to imagine, how did this thing just evolve by accident, one piece at a time over millions of years? Because again, evolution has no purpose behind it. It's not like you had a creature living millions and millions of years ago saying, you know what, I've heard really good things about ears. I think I'd like to get some for my great-great-great-great-great-great-grandchildren. So I'm going to see if when I reproduce myself I can make some mistakes in my DNA, and eventually my great-great-great-great-great-grandchildren will have ears and they're just going to love them. That's not how it works. Animals reproduce themselves very faithfully over and over and over. Every once in a while you've got some mutations that make changes. Most of them are bad. They say, oh, some of them are good. And that's kind of controversial. We talk about that in our other DVD, that evolution probable or problematic, but they say that's how it occurs. So again, there's no purpose. And how could this ear function along the way with all of its parts there? So let's take a look at the ear next. We're going to start out talking about sound itself. Sound works in this example with a speaker by the cone, which is paper or plastic, just going back and forth. And that disturbs air particles that are right in front of it. So it compresses air particles, and then when it goes back again, it decompresses them, expands them, and then compresses and expands back and forth, and eventually it reaches your ear, and it travels about 740 miles an hour. Now, it's not like a single bullet that leaves the speaker and goes all the way into your ear. It's more like cue balls, that one ball hits the next, and goes all the way across the room or whatever, and then it just disturbs the particles that are already sitting in your ear. Now, here's a diagram of the ear itself. We're going to look at the outer ear, the middle ear, and the inner ear. We're going to start out looking at the outer ear here, talking about the auricle. That's the thing that sticks out the side of your head, and it just so happens to be shaped in such a way to capture sound frequencies that your brain can interpret. There are many other frequencies out there, including the frequency of my remote that I'm using, but it's not bothering anyone because your brain doesn't really even capture that, so it doesn't disturb you. But it does capture the frequencies that we can understand. A little side note very quickly here. Most of us have a very small bump on the back of our ear, And the reason I bring this up is this is actually evidence that we evolved from an ape-like creature. Now, some of you are thinking, this guy is just not funny. I'm actually not putting this up here to be funny. This came off of a site promoting evolution. They actually think this is evidence because of the little bump there on the monkey's ear. You can see how desperate they are for evidence. But getting back to the ear again, we're going to look at the external auditory canal. And what's interesting about this is you've probably seen one of these contraptions before, hopefully use some once in a while. Well, you don't want to take one of these things and jam it all the way in your ear. That would be a bad thing. So how do you get all the stuff that accumulates way inside your ear? How do you get that out? Well, scientists have studied and they've determined that the cells that line the inner ear there are the only cells in your entire body that grow sideways. So it's like a conveyor belt that traps all that stuff and moves it out for you. Isn't that cool how that happened? Aren't we lucky that the cells in our eyes don't grow sideways, or we wouldn't be able to see anything? But they grow sideways there. Also, the wax that's inside your ears, they have an antibacterial property that kills bacteria. Isn't that cool how that just happened by accident? Then we're going to take a look next at the tympanic membrane, or the eardrum. These things are incredibly sensitive organs. If you were to take a look at a skyscraper, do you guess that there's more pressure on the steel that's at the top of the skyscraper or the steel that's at the bottom holding up the weight of everything else? Well, it's kind of obvious there's going to be more pressure at the bottom because it's got all that steel above it. Well, it's the same thing in our atmosphere. There's more pressure at the bottom than there is higher up. So if you were to travel up a mountain 1 mile, you would experience a change in pressure of about 1/2 of an atmosphere, which is about 7 pounds per square inch. But you know what? You don't have to travel 1 mile up a mountain for your ear to sense a change in pressure. All you have to do is go up 1/30,000th of an inch, and your eardrum can sense that change in pressure. That's less than the thickness of a Glad wrap sheet. So try this when you get home. Get some plastic wrap out, put it on the ground, and then step up onto it. Don't trip. And then your eardrum says, hey, the air's a little thinner up here. That's how sensitive it actually is. So that was the eardrum. We're going to move quickly into the middle ear here now and see what happens here. The middle ear houses the 3 smallest bones in our body, the malleus, incus, and the stapes. And this is what it looks like. We've got the pink part here in the middle that looks like the eardrum there. It's like a balloon. They also call it the hammer, the anvil, and the stirrup because it looks like those objects. And this is how it functions. The purple thing, gray thing going back and forth there, that is that eardrum, like a balloon. The air particles hit it, it just goes back and forth. That's connected to one of those small bones, the malleus, which is then connected to the incus and the stapes. Now the stapes, that last little bone, is like a little plunger, plunging back and forth into the inner ear. The inner ear is filled with fluid, so there are shock waves then that go through that fluid, and we'll get to that in a second. Now what's actually going on in the middle ear? Well, there are a number of things. First, it increases the sound volume by about 30 decibels. It's pumping up the volume. Why is it doing that? Well, once it gets into the inner ear, into that fluid, the sound drops way down. If you've ever gone swimming in a pool and you go underwater, you could scream your head off and your friends can't really even hear you because the sound gets decreased way down. So first it gets pumped way up before it's going to be decreased in the inner ear. Secondly, there are little tendons on that malleus that can grab it in case the sounds outside of your head are too loud. If there's a jackhammer going off by your head, what will happen is these tendons will grab that bone and stop it from vibrating too much to lessen the damage to your ear. Thirdly, it'll cancel out your own speaking. As I'm speaking right now, my vocal cords are vibrating quite a bit. It's making a lot of noise inside my head. But these tendons can cancel out my own speaking so I can still hear other things. Otherwise, I won't be able to hear anything else that's going on while I'm talking. Lastly, here we've got a eustachian tube. What happens here is if there's any fluid that accumulates in the middle ear here, it can drain it out. But even more importantly probably is if you've ever gone up in an airplane or you go up in a mountain, sometimes your ears get kind of clogged and you can't hear very well. Well, what happens? You yawn or chew some gum and your ears pop. That's this tube opening up to equalize the pressure. Because what happens is when you're on the ground, the pressure inside your ear and outside your ear are the same. So that balloon, that eardrum, can go back and forth when the particles hit it. Then you go up a mountain or in the airplane, the pressure inside your ear is still the same as it was in the ground because it's kind of trapped, but the pressure outside is lighter. So now there's more pressure inside your ear pushing out on that eardrum than there is on the outside. So the particles can't make it go back and forth like it needs to, so you can't hear as well. When you yawn or whatever, the tube opens up, it equalizes pressure on both sides, pops, and then you can hear well again. Isn't that cool how that just evolved by accident? That was the middle ear. We're going to quickly move into the inner ear, the most interesting part of the ear. It comes in two halves, left and right. We're going to start out looking at the left half here, and you'll notice that there are three semicircular tubes there going on, and this has nothing to do with hearing, but it has everything to do with balance. Just like a gyroscope can detect motions in any different direction, so can your inner ear. And we're not going to go through all the detail, but each of those tubes is filled with fluid. It has calcium carbonate crystals floating on the top, some little hairs that are connected to nerves, and this is how it functions. On the left side of the screen here, we've got a man standing up next to a box. You can see what's going on in the tubes there. When he bends over to pick up a box, the tubes move and the fluid moves. That moves the crystals, which causes signals to go through the nerves into the brain, and it tells the brain, hey, you better put some pressure on your toes or you're going to fall over and crack your head open. So this is what's going on in that portion of the inner ear. It has everything to do with balance, but nothing to do with hearing. So if you ever get kind of dizzy, it's because something's going on here with these tubes. Next, we're going to look at the right side of this inner ear here. This is the cochlea. It looks kind of like a snail. Picture it being a snake all coiled up. We're going to uncoil the snake, stretch it out, and cut it in half to see what's going on inside. And when we do that, this is what we see. We see three chambers, top, bottom, and middle. Now remember that last little bone, the stapes plunging back and forth, causing shock waves to go through the fluid? Picture yourself looking at the head of a snake and the tail is out away from you, and you've got that little bone, you're plunging in its mouth, you're causing shock waves to go through the fluid in the top of the snake. So those shock waves go through the top of the snake. When it hits the end, there's a little hole connected to the bottom chamber. Those shock waves come back through the bottom, and when it goes through the top and comes back to the bottom, it disturbs the stuff in the middle, keeping it very simple. This is what the stuff in the middle looks like. On the top, there's a little purple thing. It's called the tectoral membrane. When those shock waves go through the top of the snake, the tectoral membrane goes back and forth. When the shock waves come through the bottom of the snake, it makes this gray thing along the bottom, the basilar membrane, it makes it go up and down. So now that's all sound is. It's this tectoral membrane going back and forth, the basilar membrane going up and down. Before that, it was shock waves going through fluid, and that is going to then create electrical signals in the nerves going to the brain. It actually converts it to a digital signal. Amazing. So what we have here is then signals coming out of that inner ear going up into the brain. What do you think the brain did the first time it saw digital signals coming its way? It might say, wow, this is kind of cool, but I have no idea what to do with them. You know, how would that work, taking millions of years to figure out how to convert digital signals into something useful? It's not going to work that way. And if you've ever dropped a pebble in a pond, you know it causes ripple marks to go out. If you drop two pebbles, then you have two sets of ripple marks. When those waves go out, they crash into each other and they create what we call an interference pattern. Well, that's what sound is. Every sound that's going out is vibrating air particles in all different directions, and they're all hitting each other, crashing into each other, creating these patterns. And it's coming into your ears, and it's just vibrating those air particles going through that whole path we just talked about. Now let's look at a practical example. Let's say that we're inside a restaurant. Let's think of all the sounds we might hear in a restaurant. Again, each one of these just vibrating particles. First of all, we have music playing over the ceiling speakers. A friend placing his order to the waiter, another friend talking on their cell phone, another friend telling you about their day, conversations at other tables around you, noise from the silverware usage, noise coming from the cooks in the kitchen, a baby crying at a table behind you, pouring rain hitting the roof, then you've got traffic driving by and a horn honking, and then a police siren off in the distance. Each one of these sounds is just vibrating our air particles. Think about the police siren. That could be a half a mile away. Vibrating air particles a half a mile across the city hitting the window of the restaurant where you're at. It's actually vibrating the glass on the window just a little bit, which then vibrates the particles on the inside of the restaurant, comes all the way across into your ear, vibrates those particles, fighting all these other waves, and then going through all that path, and your brain sorts all of this out. And even though a friend of yours is talking to you directly about their day, you're listening to the cell phone conversation because it's more interesting, and your brain figures all that out. You even hear sounds that you don't hear. What do we mean by that? Let's say you're at a football game and your friend says, wow, what a play. Did you see that blank in the end zone? Let's say he turned his head so you didn't quite hear that. Well, you saw it. It was an amazing catch in the end zone. What your brain will often do is it'll go through a list of possible words and it'll throw one in there so you don't even realize you didn't hear the word. And your brain is processing all this instantly. It's absolutely amazing. That was a quick overview of the human ear and how hearing works. This is actually our first baby picture. This is our humble beginnings. This is the human zygote, a fertilized egg. These things are so small you can fit about 10,000 on the head of a pin. And inside this miniature goop here is all the information programmed to design that ear, every single element that we just went through. You know what else is inside this goop? Information how to program your heart. What do you think evolved first by accident? Your heart or your blood? Well, you got to have a heart, and you can't live without a heart, right? Yeah, what good is a heart without blood? Okay, you're right, blood evolved first. But what good is blood without a heart to pump it? It's like, okay, you're right, I know, we got lucky. The heart and blood evolved all at the same time and it worked great. What good is that without a set of lungs to get oxygen in your blood? Okay, you got me there. Okay, lungs evolved first. What good are lungs without heart and blood? Okay, we got really lucky. Heart, lungs, and blood all evolved at the same time, working together just perfectly. What good is that without a set of veins and arteries to distribute it throughout your body? And on and on and on. It's not going to happen one piece at a time by accident. So I agree with the psalmist when he says, I praise you because I am fearfully and wonderfully made. Most of you have heard this verse before. Hopefully it means even more to you now just looking at the human ear. We could have looked at the eye or many other things showing us that God is the author of life. One other quick example, this one is particular for the kids, and my mom would be mad if I left this one out. She loves this one, the woodpecker. Most of you have seen woodpeckers before. They're fascinating to watch. Here's the same challenge that I gave you with the human ear. As I describe the woodpecker, and this one's going to go fast, I want you to imagine, how did this guy evolve by accident one piece at a time? How did he survive along the way as he's waiting for all these things to come into place? He's got a number of special features: claws, tails, beak, brain, skull, and tongue. Could go through each one of these very quickly. He has a set of special claws in the back of his feet so he can perch vertically on a tree. Most birds can't do that. They go horizontal. He has a special tail and muscle attachments to brace himself very firmly against that tree so he doesn't fall off, because he's hitting that tree so hard, in fact so hard, if he turns his head the wrong way, he'll snap his neck and he'll be done. So he has to aim very accurately. Well, in order to aim, you've got to look at what you're doing, right? So he has to have his eyes open. But you know what? If he doesn't close his eyes when he hits that tree, his eyes will pop right out of his head. So he's got to close his eyes. But then when he backs up, he's got to open them to aim. So he's opening and closing his eyes. So when he's going hitting that tree, his eyelids are opening and closing that fast. Now his brain would have to be programmed to control that. Now I've done computer programming for about 18 years before going into full-time ministry, and I actually got paid for it. Now why would someone pay me for programming? Because it doesn't happen by accident. So how would the programming of the bird's brain happen by accident? Then we have a special skull system with the woodpecker. It has a shock absorber cushion around its brain. Can you imagine why it might want one? You know, any other bird that would try this would knock itself silly and end up going to McDonald's for supper. But the woodpecker can protect its brain, so it's no big deal. But the most interesting thing about the woodpecker is its tongue. Most birds and other animals have pretty short tongues. So even if it got a hole in that tree, how's it going to reach all the way in there to grab a bug and bring it out? Well, a woodpecker has a tongue that's up to 1.5 times the length of its entire body. That's an incredibly long tongue. Humanly speaking, if you're about 6 foot tall, you'd have a 9-foot long tongue. Where would you put something like that? You store it in your throat, you choke to death. If you choke to death, you can't evolve. That's a problem. Well, if you take a look at the head of a woodpecker, this is what it looks like. And if you were to remove all the feathers, and don't do this when you get home, this is what you'd see. The tongue comes into the beak. It goes out a hole in the bottom of the beak, splits in two, goes up the backside of the skull, and gets anchored in the right nostril. And then it can stretch that tongue out to grab those bugs. This is what it looks like. How in the world did all that happen by accident? Here's another question. How does a woodpecker get a bug on the end of its tongue? It actually glues the bug to the end of its tongue. Anybody see a problem with that? You glue the bug to the end of your tongue, you bring in the bug, you swallow your tongue, you choke to death. You can't evolve. Well, the woodpecker just happens to have a chemical or an enzyme to dissolve that glue so it can loosen up the bug and swallow it without choking on its tongue. Isn't that neat? How did that happen all by accident, one piece at a time over millions and millions of years? It's also interesting to note that we have fossils of regular birds and we have fossils of woodpeckers, but nothing in between. I think the woodpecker was designed by God right from the beginning. So what we've seen is that I believe science behind the origin of the universe, origin of life, and origin of species continually and constantly confirms that God's word is true and we can trust it from cover to cover. Jeremiah 32:17 says, "Ah, sovereign Lord, you have made the heavens and the earth by your great power and outstretched arm. Nothing is too hard for you." Psalm 118:8, "It's better to trust the Lord than to put confidence in man." We can trust God's word from cover to cover, and we need to do that. I think this has been kind of an interesting look at science. There are tons of other things that we could cover, but I hope you were encouraged by this. We don't use science to prove anything. Science is really all about interpretation. We're looking at some raw facts and interpreting what does it actually mean. We actually believe that God does exist, and the Bible is His inspired word, and really nothing else makes sense without starting at that point. But science, I think, can be interesting, and a lot of questions do come up along the way, so we put together a presentation like this just to address some specific things. And again, we trust that it was an encouragement to you, and we look forward to seeing you again. God bless.
We hope you enjoyed this presentation and trust it was an encouragement to you. For more information about our ministry and resources, visit us online at thestartingpointproject.com.